Hi and welcome. I am trying to learn electrical engineering today, the secondary cell. And after we've done with it, we're going to do extensor cardiopulmonary strength training. And if you participate in the extensor cardiopulmonary strength training, dann ist wieder die Augen and the extensor cardiopulmonary is here. Okay, this is part 2 of a simple set. We're telling now basically about the car battery. The metal plates of an accumulator are separated by wood or plastic sheets to make the battery robust and able to withstand fairly rough handling. Okay, a car battery. The first thing is, a car battery consists out of 6 2-volt cells next to each other. And now they are having in the middle some plastic or wood, so that they don't bump into each other and go broken. Number 4, the plates are covered by dilute sulfuric acid. Okay, I don't know what it means now. Maintenance of an accumulator. A lead acid accumulator is an efficient device with a long life, provided it is maintained and used carefully. Okay, let's go one back what it all was. The principle of a lead acid accumulator can be shown by a simple experiment. 2 lead plates should be immersed in dilute sulfuric acid, half water, half acid. A 2.5 volt lamp bulb connected to the 2 plates will not light. There is no energy available. Now a current should be passed through the cell by connecting a low voltage supply of about 4 volt to the lead plates for a few minutes. When this current supply is removed and the lamp bulb again connected to the plates, it will glow, showing that the cell has stored some energy while the current has been flowing through it. Okay, I don't know if it was somebody explained how it works, but that is how the battery is charged. Now, how to maintain a good accumulator lead acid double lead plate battery. Number 1, the charging rate, in example current, is suggested by the manufacturer. Charging with a larger current is likely to cause the plates to buckle and disintegrate. I don't know what buckle means. And I don't really know what disintegrate means. I used the word previously, but I don't want to describe it. It would be difficult to write in what circumstances. And the second thing is, now, if the electrolyte evaporates, the level has to be made up by adding distilled pure water. If the electrolyte evaporates, the level has to be made up by adding distilled pure water. Okay, the electrolyte, that is the dilute sulfuric acid, half water, half acid, and this water is going away over time, and that has to be refilled. Are there people refilling the car battery? Whatever. If, however, the liquid is spilled, it must be replaced by dilute sulfuric acid of the proper relative density. Whatever, we're saying a car battery can be fixed. Whatever, don't do it yourself, that is dangerous. Number 3, an accumulator must never be short-circuited, because its internal resistance is very low. A short circuit would allow a very large current to flow through the cell, and again the plates would buckle and be damaged. I don't get it. They should get too much charge, more than they should get. They should be not short circuited. You should not put the 2 plates together. I don't know. Number 4, the state of charge of an accumulator can be ascertained by using a battery hydrometer. When fully charged, the acid will have a relative density of 1.25, and when fully discharged, a value of about 1.18. The density of the acid changes through charging. When the cell is discharged, the plates are covered with a layer of white lead sulfate. It is undesirable for an accumulator to be left in a discharged condition for long periods, otherwise this layer of lead sulfate becomes thick and hard to remove. The cell is then said to be sulfated. That means there's a chemical explanation why car batteries should not be empty over too long time. Because there is for some reason this lead sulfate on top of the lead plates, and that would get hard over time. Number 5, the terminals on top of, did you not say 4 things? Number 5. The terminals on the top of an accumulator or battery tend to become corroded by the acid, and periodically the terminals should be cleaned and lightly greased. I don't know what greased means. Whatever. Some type of terminal on top of some type of car battery gets over the time dirty and should be cleaned again. I don't know if it's dangerous. The chemical reaction in the lead acid accumulator are little involved. In brief, both plates are made of spongy lead before the accumulator is charged. Okay. The two lead plates, which are inside of an acid sulfuric electrolyte, that's liquid or whatever, they are spongy before being charged. When charged, the positive plate becomes covered with a layer of lead 4 oxide, a red-brown substance, while the negative plate is lead, grey in color. Somehow one of these two lead plates is positive and the other one is negative. And that has the thing to happen now, that the positive one gets covered with lead 4 oxide, a red-brown substance. And that makes a bit sense. There is a positive plate, because it is positive, it bounces with other things than a negative one. If there's a magnet and it is at that point magnetic with the positive side, it goes to this metal plate. Otherwise, if you turn it around, it will go away because this negative side does not want to go to the metal piece. And it seems to be the same here. If a positive plate, it does want to bound up to connect with some type of elements inside the sulfate, inside the water acid sulfate. So if it's charged, there's movement happening or whatever, or they are going from one side to another somehow, and that causes the ones to bound with the positive side because the positive side accumulates them by it. And that way it can be charged, so there would be something changed. It is now covered with a sulfate 4 oxide cover, whatever. A lead 4 oxide cover. Oxide was at least in the water. So, and the other one is just with lead or whatever. When the cell is discharged, both plates become covered with a thin layer of white lead sulfate. The relative density of the acid in the cell varies according to the number of sulfate ions in it, and hence this indicates the state of charge of the accumulator. Okay, when it is discharging, the reaction is the other way around. And because it is the other way around, some atoms going away from the positive thing, and that movement transports the atom. But while these atoms are going from the positive lead thing to the negative thing, there's movement happening and electrons are flowing. And flowing electrons are current and electricity. Okay. The relative density of the acid in the cell varies according to the number of sulfate ions in it. Where are now the sulfate ions from? Having half water, half acid and lead. Where do we get sulfate? Immersed in a dilute is sulfuric acid. So it consists out of sulfur, but liquid dilute sulfur, which is half water and half acid, but it is the element sulfur, or whatever. Now, and this sulfur has a relative density of 1.25 if charged and 1.18 if not charged, because of the number of sulfate ions in it. Why are the sulfate ions in it? Because the negative sulfate ions going to the positive lead thing. I guess that would be an explanation. Increasingly common are alkaline secondary cells, usually known by the trade name of NiFi cells. The plates are made one of iron and one of nickel hydroxide, with other substances added. Usually alkaline cells are enclosed in a steel container. The book is from the 60s and revised in the 90s, so I don't know. Usually alkaline cells are enclosed in a steel container. This is not corroded by the electrolyte, which is a solution of potassium hydroxide. By saying using a steel container does not corrode it because for some reason steel does not react with the other thing. Alkaline cells are not as efficient Yes, it has to do with the number of atoms, with the number of electrons and so on inside the different atoms. So why does steel not react with one thing and the other thing? Because they are completely different things. It is because some things have 1 or 2 protons, other things have 100 protons, and they don't want to bond together if they are. I don't know exactly how it works, but it has something to do with it. That some elements have 1 to 5 protons, others have 50, and that makes them not to go together like that. The plates are made, alkaline cells are not as efficient as lead acid cells, and they are rather expensive. On the other hand, they are low in weight for a given capacity. They also withstand high rates of charging and discharging, often very desirable in laboratory work. Okay, we're saying that how it's set up, which we have at our 2 leads in our sulfur dilutic acid water mixture, works by bringing the negative lead things, the negative sulfur things to the positive plate by charging, because the charging brings them all moving, and therefore they're going there, whatever. And discharging the other way around, then they are breaking it, whatever, they're going to be upset. And the whole thing can be done with completely other substances. I'm not going to use that example. You can build a bridge out of stone or out of wood, and they have both positive and negative things. And now instead of using this dilute sulfuric, people can also use alkaline, and there's no potassium hydroxide in it instead of sulfur. Whatever the basic thing is, there are no other atoms in it with other amount of electrons and protons, and because they have other one, they stick with other one and go together. And now using some type of alkaline thing, they are able to be charged at a higher rate, because the atoms, for some reason, it's just another number. They have 60 instead of 50, and that makes our own calculation differently. If something has 60 electrons, it sticks differently together with something with 50. Basically like that, I don't really understand it. But just some people, to give a little over how is now that differently. That is basically what is happening there. And yes, that is it. So the same thing just with other substances. They work differently because they have other amount of electrons on their shells. The atoms have more or less electrons and stick differently together and behave differently. Now alkaline is possible to charge and discharge at higher things, and they are lower in weight, but they don't have so much capacity, I think. Was the also thing. Now it was the electrical engineering part. If you were here for electrical engineering, you can go directly to the next part of electrical engineering. If you stay here and participate in the extensor strength training, then it's at your own risk. And again, this is at your own risk. So the hands next to us, and we're doing the floodgate, the fists, and we're bringing them down and up. Now we're having 3 rules. The first rule is we're stopping immediately as soon as there's pain. The second rule is that we're going only as fast as we can go with a little bit of effort. We're not forcing anything here. And the third rule is that we're not overdoing it. We just want to strengthen, not exhaust. Next exercise, the counterfeit money check fists, and move them upwards and bring it down. And now the next exercise. You're going to use a t-shirt, towel, or whatever. Press with good force onto it, and bring it again up. And down. And again up. And now, flatten. And turn to the outside. Press evenly with the whole hand, with good moderate force. Evenly with the whole hand, pressing with the 4th and 5th finger evenly. To the outside again. Only as far as it goes, no pain. And to the inside. And now, straight. And bring it down. And you get down. Other side. Press. And bring it up. And now, turn to the inside. Outside. And now just press neutral position. And on the other side. and we actually had more time, but was it? I thank you very much for participation. I thank you very much in it.